Okay, hey Megan. We got through 4-1. We're doing 4-2 notes now, and 4-2 is kind of a beast, and it talks about the unit circle. Okay, so I'm gonna give a lot of background info. I'm gonna put some stuff over here, but I told them get out your pink sheet so you can look at your unit circle. Get out your notes, these notes. Get out your calculator and a pencil if you want to write any of this stuff down. So here we go. All right, so angles. All right, so we're talking about angles, and they do some stuff with sine and cosine on what's called the unit circle. Okay, unit circle meaning. Here's what it means when we're talking about a unit circle. Unit meaning one, right? Unit, one. The radius of this circle is 1. Okay, now we did equations of a circle a while back, right? And the equation of a circle looks like this, except it really looks like this. X minus h, you don't write this down, plus y minus k squared equals the radius squared, right? If the radius is 1, then 1 squared is 1. But this guy is centered at 0, 0, right? So instead of it being x minus 0 squared, they just write it as x squared, y squared, right? Like that's how they write it. So the equation of this circle that they've slapped on this coordinate plane is this guy, x squared plus y squared equals 1. Now, the deal here is there is a trig function that involves sine and cosine that says that cosine squared plus sine squared equals 1, right? Like anytime you do, I should say x, right? Anytime you do stuff like that in your calculator, it comes out to be 1. So like let's say I'm taking cosine of 30 degrees. If I square that and I add that to sine of 30 degrees, don't write this part down. You can write this down. And sine of 30 degrees, if I type this into my calculator, it's going to end up coming out to be 1. If I change that to 150 degrees, right? Or if I change that to 210 degrees, I have no idea. If I change it to anything and I square them, no matter what, the answer will end up being 1. So the deal here is they are using this unit circle, and they are using the unit circle to represent cosine is the x coordinate and sine is the y coordinate. All right, on your unit circle, on your pink sheet, in the very, very top right corner of your pink sheet, pretend this is your pink sheet, you have a little thing up here that says x comma y equals cosine x comma sine x, or cosine comma sine. That means that, this is the very most important thing about reading your unit circle. That means when you're looking at this, the cosine value corresponds to the x coordinate. The sine value corresponds to the y coordinate. All right, now, this unit circle, this pink circle, is kind of like having access to a calculator right now, right? So here's the deal. Let's say, like we do right triangle trig and we do like sine, cosine, and tangent and all this stuff, right? Okay, let's say, and you have on your unit circle, I think you have tangent and all the things marked out. Okay, so let's pick on like, I don't know, 60 degrees. Okay, let's pick on 60 degrees. Let's say I want to know what cosine of 60 degrees is. I can certainly type that into my calculator, right? Or I can look on this unit circle, what will cosine of 60 degrees be?
60, 60.
Cosine corresponds to the x coordinate. What's the x coordinate at 60 degrees? These guys right here. 1/2. That's it. Like my calculator, I'll type it into the calculator, and cosine of 60 degrees is 1/2. Or 0.5 if your calculator rounds it off, right? Let's go to, like, let's say I have 240 degrees, and I want to find sine of 240 degrees. What will sine of 240 be? Negative square root of 3 over 2. It's the y coordinate at that point, okay? Now, we're going to go over here in a second where these even come from. Like, did they just pull them out of nowhere? I don't know. We'll talk about where those come from. But this is like having a calculator. Okay, let's do this. Let's say I want to find sine of 7 pi over 4. This is now a radian. Okay, first find 7 pi over 4. What quadrant is 7 pi over 4 in? The fourth quadrant right here, 7 pi over 4 or 315 degrees. I want the sine value. Sine is which one, x or y? Y. So I just want the y coordinate. Negative square root of 2 over 2. If you type in sine of 7 pi over 4 into your calculator right now, it will give you the wrong answer because your calculator is probably set to be in terms of degrees. So I could type in sine of 315 and it would give me negative square root of 2 over 2, right? Negative, and 315 is the same thing as 7 pi over 4. It would probably give you like negative 0.878 or 8707 or something like that.
0.0958073.
Okay, maybe not. Anyway, whatever. But 7 pi over 4, we would have to switch our calculator to be in radians if we want to type in sine of 7 pi over 4. Okay? So, this is like having a calculator. I have access to all this stuff. Okay, now, these are ones that you probably can memorize, maybe-ish, probably, right? Okay, so let's talk about 0 degrees, which is also the same as 0 radians, okay? If I'm talking about a unit circle and I have a circle on here, and I'm talking about 0 degrees, 0 radians, what coordinate is that at? Like, what's the XY coordinate for him? What?
1, 1.
Right here. 1, 0, right? I've gone over 1 and up 0, right? What's this coordinate right here?
0, 1.
0, 1. Do you see where we get 0, 1 and 1, 0 and all the stuff? Okay. This guy would be at how much?
Negative 1, 0.
Negative 1, 0. And this guy would be at
Negative
0, negative 1, right? Okay. So let's say I want to know what cosine of 0 is. Cosine. Cosine of 0. So I go to 0. Cosine is the x coordinate. So cosine of 0. Cosine of 0 equals 1. Okay. Let's say I want cosine of pi. Where does pi live? I want cosine of pi.
Negative 1.
Yeah, pi is over here, right, at 180 degrees. And cosine is the x coordinate. So cosine is negative 1 at pi. Yeah? Okay, let's say I want sine of 270 degrees. What is sine of 270? 270 is down here, right? 270 is 3/4 of a turn. And the sine is the y coordinate. So negative 1. Again, I can type all these into my calculator, and that's what it will give me. But it's like having this information on a unit circle, right? And it all has to do with the coordinates. Got it? Do we understand that, or do we need to go through a couple more? Let's do sine of 360 degrees. What's the sine value of 360? 0. Sine is y, right? So we're going here. 360 is the same as 0 degrees, and the sine is the y coordinate. So sine of 360 is 0. Got it? Do we see how this works? Okay, now, how do they get all the other junk in there? Like, I understand where, let me get rid of this crap. Hold on. Un momento, por favor. Okay, I understand where they get this guy. Like, this information makes sense to me. Whoop, whoop, whoop. Let's go over that information. So, we know that 0 is the same thing as 0 degrees, and 2 pi is the same thing as 360 degrees. We know that, right? And those all live right here. And that coordinate is 1, 0, because from 0, 0, I go over 1 and I go up 0, so 1, 0 is there. 90 degrees is the same thing as pi over 2. Do we know that yet? Like if I said, what is 90 degrees in radians, and you would say pi over 2. Do you know that yet? That's okay if you don't. We'll get there. 90 degrees is the same thing as pi over 2, okay? Why is it this coordinate? Because from 0, 0, you go over 0 and up 1, so 0, 1. Okay, over here, 180 degrees is the same thing as pi. Do we know that yet? Yes? Okay, 180 degrees is pi. That's negative 1, 0, because from 0, 0, I go negative 1, 0. And 270 is the same thing as 3 pi over 2. Do we know that yet? Got that in our brains? Maybe? 3 pi over 2 is 270, and that's 0, negative 1. Okay, that's his coordinate, okay? So those guys make sense, hopefully, maybe. I don't know. Do they make sense at this point? Maybe. Okay, so these guys are done. We know these guys. These guys make sense to us. All right, I'm going to do this first. Let's pick on this 30-degree mark. Let's make sense of this guy, okay? Okay. All right, just absorb. Don't write anything down, okay? Here's my unit circle. Whoop. And 30 degrees lives here. And what I'm going to do is I want to make this into a right triangle, and I want to figure out what the x coordinate is and what the y coordinate is to get to there, right? Okay? So the deal here is, are we ready? This is 30 degrees, okay? Do you know, like a 30, 60, 90 triangle? I'm going to pretend. This is 30 degrees. This would be 60 degrees. This is 90 degrees, right? Okay, do we see how that works? Okay, a 30, 60, 90 triangle. I put this little imaginary triangle on the bottom of him, and I made him into an equilateral triangle, because this would be 60, this would be 60, and this would be 60, right? Let's say that equilateral triangle has all sides that are 2, right? Okay, don't write this down. If that's all 2, what would the distance from here to here be? 1. If I do the Pythagorean theorem to find out what this side is, right, I would do, let's call this guy x. X squared plus 1 squared equals 2 squared, right? This is 1, this is 4, so x squared would be equal to 3, and this is the square root of 3, right? Okay, so this little guy right here, whoop, is the square root of 3, okay? So a 30, 60, 90 triangle will be 1, 2, square root of 3. Did we talk about that in geometry last year? 1, 2, square root of 3. Okay, so that is that. All right, I have 1, 2, square root of 3. That's what he looks like. All right, now, let's talk about these 2 coordinates right here. How far do I go over? How far do I go up? All that good stuff, right? Okay, so this guy is the cosine value. This guy is the sine value, right? Okay, do we know how to find sine, cosine, and tangent? Sine, do we know SOHCAHTOA? SOHCAHTOA. Sine is OH. So if I'm looking at this triangle right here and I'm talking about this 30 degrees, what's the opposite of him?
The 90 kind of thing, or 1.
1, right? Opposite of him is 1, and the hypotenuse is 2. 1/2. Okay, cosine is the adjacent over the hypotenuse. So which side is adjacent to this angle? The square root of 3 is adjacent, and the hypotenuse is 2. Look on your unit circle really quick at 30 degrees. Is the cosine value the square root of 3 over 2 and the sine value 1/2? That's where that comes from. So that's just telling you how far you go over and how far you go up, or whatever, to get to that point. The cosine value, the sine value of 30 degrees is that. Got it? Yep. Okay. We have how much? 5 minutes? All right, let's do 60 degrees and then we'll be done. 60 degrees. Okay, I'm going to pick on 60. I'm going to skip over 45 because I'll show you 60, and here's why 60 is important. 60 degrees is pi over 3. Here you go. Ready? 60 degrees is pi over 3. Pi over 6 is 30 degrees.
They're the inverse.
They're kind of, yeah. Like pi over 3 goes with 60. Pi over 6 goes with 30.
They're just opposite.
They're kind of opposites of each other. Okay, so there's that. All right, let's go 60 degrees. All right, so here we go. If I draw this guy, don't draw this guy. Just watch, okay? 60 degrees is going to be up here. Okay, I'm again making him into a triangle. 60 degrees is this guy. I want to know what this guy is, and I want to find his coordinates. All right, so this guy is also a 30, 60, 90, except your 60 is down here and your 30 is up here, right? Okay, so if I think about him as an equilateral triangle, right, with all of the sides being 2, we'll just pretend that all of the sides are 2. Like this side is 2, this side is 2, this side is 2, right? What is this bottom side right here? 1. What's this guy right here? The square root of 3, right? So I have 1, square root of 3, and I have 2. Okay. All right. Now I'm picking on this 60 degrees right here. And I want to find cosine, and I want to find sine, all right, to find those coordinates. Sine is opposite over hypotenuse. What's the opposite of this guy? Like this angle right here. The square root of 3. And what's the hypotenuse? 2. Okay. If I want to do cosine, cosine is A over H. What's the adjacent side to this guy? 1. And what's the hypotenuse side? At 60 degrees. Is it 1/2 comma square root of 3 over 2? Yes. That's why. Because it's a 30, 60, 90 triangle, and it's 1, 2 square root of 3. That's how they find that. Okay? All right. We will continue more a little bit tomorrow because I don't want to overload you, and I think that's a lot already. Like, it's a beast. Okay? All right. There we go. Goodbye, Megan.